All right, so today we're going to start looking at some Algebra 2 topics, something to get you a little success, and they are extensions for Algebra 1. So I want to make sure that you get them. And we're going to start out with a factoring review. So we're going to review factoring, but we're going to take it just a little bit further than you did for pre-AP Algebra 1. So if you recall, factor by grouping, we call it factor by grouping because we group things together and we factor out the greatest common factor. So here, my greatest common factor is 5x. And if I factor that out, I'm going to get 4y minus 1. From my second pairing, the greatest common factor is 8r. And if I factor that out, I'm also going to get 4y minus 1. Remember that that's key. We want those to be the same. This has to be the same as this, and that is one of my final factors, and then what we pulled out is the other. So this factors to 5x plus 8r times the quantity 4y minus 1. And then we should always check to see if they can factor again, but in this case they can't. There's no greatest common factor, there's no difference of squares, there's nothing else that we can factor out. Okay, now sometimes we have to regroup when we are doing factor by grouping. If we were going to factor out the greatest common factor as it is, here it's just 5, and we would get 5a squared c squared minus 4bk. And while here, there isn't a greatest common factor, so there's nothing we can factor out. So what we want to do is we want to turn things around. Now, on your notes, this might say plus here, but we need to change that to minus in order for that to work. So make sure that you've done that. Okay. Now, I'm going to regroup. So I've got 35a squared c squared, and I know that 25 is also divisible by 5, and it's got the a squared in there. So I'm going to group those together. And then I'm going to go with the ones with the b's, but I want to make sure, because 35 is larger than 25, I'm going to put my 28 first. So 28b squared minus 20bk. And now here, my greatest common factor is going to be 5a squared out of the first pair. And when I factor that out, I get 5a squared and 7c squared plus k. Here I'm going to factor out a negative 7b, and I'm going to get 4c squared. Oops. Going to factor out a negative 4. And I knew I was wrong right away because the binomials weren't going to be the same. So that's going to give me c squared plus k again. So now my factors are 7c squared plus k and 5a squared minus 4b. And the binomials can't be factored. Okay. Now with the quadratic, same process, we're simplifying, but these are going to have higher powers. But the first thing I want to do is I'm going to factor out a 2, my greatest common factor, and I'm going to get 2 times x to the 4th plus 3x squared minus 20. Now notice that the exponents, the middle term is half the first, and that's what it has to be, the degree, in order for this to work. And then we just need factors of negative 20 that add to negative 10 that add to 3. And those factors are going to be 5 and negative 2. So if I split the middle term, x to the 4th minus 2x squared plus 5x squared minus 10. And then I can do factor by grouping. X squared, I'm going to factor out, so I get x squared times x squared minus 2. And then I can factor out a 5 here, and I'm going to get x squared minus 2 again. So my factors are x squared plus 5 and x squared minus 2. Okay. And with these, again, I want to look to see if something can be factored, and they can't be factored any further. Okay. Now this time I've got u to the 8th, u to the 4th. They're half each other, so they can be factored, and I need factors of negative 48 that add to negative 2, and that's going to be negative 8 and 6. So again, if I split the middle term, u to the 8th minus 8u to the 4th plus 6u to the 4th minus 48. Okay. Oh, and while I'm thinking of it, the last slide, don't forget the 2 was a factor as well. All right, so if out of here, I'm going to factor out a u to the 4th. So I'm going to get u to the 4th and u to the 4th minus 8. Here I'm going to factor out a 6, and that's going to give me u to the 4th minus 8 again. So my factors are u to the 4th plus 6 and u to the 4th minus 8. The only one we would want to look to see if it factors more is this, because it's got subtraction. U to the 4th is a perfect square, but 8 is not, so it can't be factored any further. Okay. Last is sum and difference of cubes. So when we have perfect cubes, we can factor both the sum and the difference, and they factor into this the cube root of the first minus the cube root of the second. Okay. And then a squared plus ab plus b squared, or minus, depending. Okay. The signs, we can use the acronym SOAP to help us remember. So the signs are going to be same, opposite, and always positive. Okay. So what do I mean? Let's look at an example. So x cubed minus 125, the cube root of x cubed is x, and the cube root of 125 is 5. So my binomial factors to x, it's going to same sign, so same. I'm going to square this first term here, x squared, multiply these, minus 5x, but it's opposite, so it's plus, and then always positive for the third sign, and we square the last 25. And so that is our final factoring. This trinomial can't be factored at all if you have already factored out a greatest common factor. Okay, let's look at the next example. 8x cubed plus 27y cubed. So now I've got 2x plus 3y are my perfect cubes, or my cube roots. Okay, so if I square this, and we're going to go with same, opposite, always positive again for the signs. So I'm going to square that. Remember, we're squaring the whole thing, so it's 4x squared. The opposite side is minus. Multiply these, so I get 6xy, and square that plus 9y squared. So here is my final factorization. And again, these can't be factored any further. Okay, now this looks like, by the way, this last trinomial, perfect square trinomial, because those are both perfect squares. But remember, in order for that to work, this middle term has to be 2 times AB. Okay, and A in this case is 2x, and B in this case is 3y. If I multiply that, I actually get 12xy, so that's why that can't be factored any further. All right, so we looked at how to factor some higher order polynomials today. We looked at regrouping with factor by grouping, and then we looked at sum and difference of cubes. Have a math-tastic day.